All right, your assignment was to complete problems 6 through 9. So we'll go through those problems. So in problem number 6, which is very similar to problem 5, we know that the y coordinate is -4. We're being asked to find the x coordinate. So to do that, we're going to be using the Pythagorean theorem. I'm going to make sure that the -4 is in parentheses, otherwise you will get a negative answer where the answer actually is positive. So x squared is equal to 9, so x is equal to plus or minus 3. Since we are in the fourth quadrant, x is positive here, so the x coordinate will be positive 3. Problem number 7, drop down the y and the x with the right triangle. This time y is positive, and we look at the x value. The x value in this problem is actually negative since we are in the second quadrant. So x squared plus 4 squared equals 5 squared. So x squared plus 16 equals 25. So x squared is equal to 9, so x is equal to plus or minus 3. And again, because we are in the second quadrant, the x value will be -3. Problem number 8, we have a circle with a radius of 10. Told that the x value is 6. So there's actually 2 answers here. Depending on which quadrant you're looking at. So the height is 6 could give me a right triangle in the first quadrant, or the length of 6 could give me a triangle in the first quadrant, but then the x value could also give me a y value in the fourth quadrant. And so therefore, the y value can be both positive and negative in this situation, since there are 2 possible answers. So if I do 6 squared plus y squared equals 10 squared, 36 plus y squared is equal to 100. So y squared is equal to 64. We'll subtract 36 from both sides. So y is equal to plus or minus 8. So in the first quadrant, the answer would be 6, 8. And then the fourth quadrant would be 6. So a periodic function, by definition, is a function that has a repeating pattern with a certain interval, and the period at which it repeats is the value that's basically being added or subtracted to the function each time you get the answer back to the original. So the clock, for example, would have been the perfect example of that from the ladybug problem. So, for example, talk about the 3, the ladybug is 10 feet above the ground. So if I go 60 seconds and get the second hand back to the 3 again, that ladybug is back to 10 feet above the ground. And if you continue to go a period of 60 seconds to get back to the 3, the ladybug will remain 10 feet above the ground at that time. If you choose a different time, the height of the ladybug will be maybe a different height, and then every 60 seconds, the second hand will return to that location on the clock, and that will also give us the same answer. So again, we are repeating the answer at a regular interval, and that interval is the period, which in this case is 60 seconds. Alright, so kind of finishing up the lesson here, they're asking us to decide what's true about the x and y coordinates of the ladybug. And one of the situations can model something very similar to a periodic function like the clock. Then starting problem 12, you'll see a lot of reviewing. So problem 12 through problem number 16. So if you please finish that up and then turn the video back on. If you want to work with a partner, that's perfectly acceptable. And then we'll go through the problems here in a few minutes. Alright, so if you consider the previous problems that we did, and also the unit circle that we started, The one thing that's being used repeatedly are right triangles. So we can use the right triangle, specifically the 30, 60, and the 45. Come up with our coordinates. We use the Pythagorean theorem to find the missing x and y values of given radius. So the answer they're looking for here is that the relation between x and y for the ladybug problem, if you have a radius of 1, is the Pythagorean theorem. So if I know x, I can find y as long as I know what the radius is. Other situations that have this repeating pattern, there's lots of examples, but I'm just going to give you one for right now, but we have a Ferris wheel. So think about a Ferris wheel, every so many minutes it returns back to the bottom. The lowest point in terms of the wheel, at some point it'll be at the top. And as long as that Ferris wheel is turning, the speed remains constant. You'll return to the bottom of the Ferris wheel at the same time and interval, whatever that period is, during the ride. All right, so problem number 12. So the cosine of angle A is 15/17. The sine of angle A is 8/15. The tangent of angle A is 8/15. Sine is 8/17. In the second part, problem 13, they're asking you to sketch a right triangle, which you have some information. We know that a right angle is an E, and the two sides are D and F. We're also told that the sine of angle D and the cosine of angle D are the same answer. So cosine is adjacent over hypotenuse, so let's call this A over H. And sine is opposite over hypotenuse. Now, if I have the same answer for both sine and cosine, the only way that happens is if the opposite side is the same length as the adjacent side. So the fractions would be the same fraction for both sine and cosine. So therefore, tangent of angle D would be opposite of adjacent, which is A over A. And so as long as A isn't 0, the answer to this problem is 1. Last problem for this page, we have 9 and 12, so we use Pythagorean theorem. The hypotenuse is 15. So the cosine of angle G is going to be 9/15. The sine of angle G will be 12/15, and the tangent of angle G, which will be 12 minutes. All right, so the problem 15 and 16 are kind of together. The length here is 12, the length here is 5, so if I use the Pythagorean theorem, I get the hypotenuse to be 13. So cosine of angle D would be 12/13. Sine of angle D would be 5/13. And tangent of angle D would be 5/12. For the problem 16, the bottom's 36, the height is 15. We use the Pythagorean theorem, I get 39. Question of the triangle is similar. Well, a couple of reasons the answer is yes. They both have a right angle, and they both have the same angle D. D and D prime indicate that the angle is in this case is being violated, so the angle is the same. Also, if you have the scale factor here, the scale factor between the DEF lengths and the D'F lengths, the scale factor is 3. So I triple the 5, I get 15. If I triple the 13, I get 39. If I triple the 12, I get 36. So by side-side similarity, the triangles are also similar. The last part of this is the cosine, sine, and tangent. So cosine would be 36/39. Sine of d prime would be 15 over 39. And then the tangent of d prime would be 15 over 36. And if I would actually simplify those fractions, what I would end up with is 12/13 from problem 15 for the first one, cosine. Sine, I get 5/13, and tangent, I get 5/12. So again, this is another support that the triangles are also similar because the ratio between the sides is actually the same answer in the simplified fractions. I'm going to skip 17 and move on to the unit circle. So if you would take a moment, hopefully the teacher will provide you the unit circle. Take a moment and kind of take a look at the answers. Make sure the answers are correct for your unit circle. Both the coordinates, the angles, and both degrees and the radians. And then transition to the second and final video. Once you're done the next lesson, which is lesson 2 of Unit 4, then you're going to be spending your time working on the Delta math assignment, which is actually due Friday this week. I'm hoping you'll have it done on Thursday, or by Thursday. So I'll try to provide some time in class to ask questions, as well as make some work time. I do want to address your Unit 3 test as well on Thursday. So please come with all your notes on the law of sines and law of cosine.